Great. Thank you guys so much. I'm super excited to be here. I love Data Science Go. It's one of my favorite conferences. Will machines ever think? What a fun question we should all be asking. And people have been asking for a long time. So before I jump into it, I'm going to tell you the story about how I learned to program. So back in 2002, 2003, I have a memory where I'm getting arrested and I'm sitting in a cop car and I'm watching these two police officers dump all of my belongings out of my backpack onto the freeway, including my SpongeBob DVD collection. I remember being very upset about this. And what does this have to do about programming? Well, it turns out that I had been living in the woods and it had gained some attention from the university presidents and media outlets. And if you remember this scene in Forrest Gump where he has all these followers that are so intrigued by everything he has to say, I actually know what this feels like. I had college students that were constantly reaching out to me, recognizing me, and it's almost like they thought I had life figured out, and I didn't. But the thing that I did start to figure out is I needed to come up with a way to share my life's journey with some of my followers and people from the media that wanted to follow me, because we didn't have Facebook, we didn't have social media. So I learned to program, learned HTML, CSS. And eventually I learned PHP because I started an outdoor rock climbing store, e-commerce store, and I had to ship product. And so my background's in chemical engineering. I do not know how to program. And I have a funny memory where I remember desperately looking for someone on campus that can fix this nasty PHP curly bracket bug that is causing an issue with my store. And I think I paid this individual $40 or $60 cash to find the curly bracket that was breaking this code, which is so funny because I just had to learn trial by fire. And many years later, so 17 years later, I eventually ended up co-founding a deep learning AutoML company, which recently joined the DataRobot family earlier this year. And one of the experiences I had while doing that company, again, remembering that I don't have a programming background, but I've kind of just been thrown into the fire. I remember doing some benchmarking with Dell where in our data center, we were benchmarking the C4140 server, which has 4, I think, V100s laying flat. It's a really good powerhouse for deep learning. And we were doing 48 hours of benchmarking, running our code on it. And Dell had software that was monitoring this. And I remember feeling very nervous that they would come back and criticize us and say, I can't believe you amateurs are running code like this. But it turns out that we had feedback that our code was running very, very fast, some of the fastest numbers they'd seen. And the joke I brought up on the call was, it's amazing how fast your code runs when you have to feed your kids, which is kind of the truth of it's the reality of doing a startup. Code runs faster, things get done because they have to, because if they don't, you die. Since joining DataRobot, some of the joys that I have with this new role is I am a co-host on the More Intelligent Tomorrow podcast, and I've had the privilege of interviewing people like some of the people you see here, but also Congressman Will Hurd, who ran the AI initiative for the U.S. government to raise awareness around our AI strategy. And I really enjoy this. This will lean into the talk about this idea of intelligence. So I feel like I can feel myself getting smarter every week as I interview these people, because they change my perspectives. They give me new topics and things to ponder. And for people that don't know, DataRobot, this is the one slide I have for DataRobot. For people that don't know, they are kind of a one-stop AI platform. They go from data acquisition, feature building, AutoML, model deployment, MLOps, version control, tracking. And they're used by, I don't know the number off the top of my head, I should know that number, but a lot of the Fortune 100 rely on DataRobot to manage their models. Can machines think? What an incredible question to be asking in 1950, and something that we still talk about with the famous Turing Test that takes place today. I remember, I think it was 2015, 16, I was doing clustering on resumes using Word2Vec. So we trained a neural network to produce these encodings or embeddings on resumes, and I was fascinated by the ability to find topics that were useful. So things like, for the word accomplishment, it'd be surrounded by words like bronze, scholarship, accolade, achievement, and all these wonderful words that feel like an accomplishment, competency in a resume, or the relationship that job families had together. I was thrilled with the value I was seeing. It made me quite negative against linguists, where I felt like they were now irrelevant. Why would you consult a human linguist when you can use big data sets and these really powerful neural networks, and they've only been getting better. One of my favorite storytelling pieces, and I have shared this before at DataScienceGO, is this one. This will always be kind of one of my favorites, where taking a CNN and training it to classify someone's face, which country they're from, we can then organize those average encodings by the countries and begin to get some type of a spatial map of the world. And this individual in the bottom right is from Greenland. And the fact that the countries are clustering together is a really fun insight that a SME or a subject matter expert would appreciate. They would see that as intuition. And this analysis was done, I think, back in 2016. I would love to repeat something like this today with the power of the deep learning models that we have today. I imagine it would be much, much better and much more mind-blowing about the insights about how different countries could relate from the deep learning perspective, but really under the hood genetically. How do these countries relate with their ancestry? Everyone's heard of GPT-3. GPT-3 is really this miracle, modern miracle when it comes to AI. These are 3 examples I've included. So our ability to translate from English into German in a variety of languages, our ability to answer questions using this really, really powerful 175 billion weight neural network, and then also do grammar corrections. You've seen it generate poetry and different things. And as we get to these models that are really, really big and impressive, keep in mind the human brain, I think, has 85 billion neurons, and so we have more weights in this model than neurons in our brain. What does this even mean? And before I kind of go on the attack, and take a look at this. This is image GPT, also coming from the OpenAI group. We're taking a top half of an image as an input into one of these models in a very similar way that they've done for text predicting next word. They can begin to predict completion on these images, and they can finish a variety of these images, and these results are quite fun. And if they're a little grainy or a little silly, just think of what's to come. So what are we going to be looking at 5 years, 10 years, 20 years from now? And here comes the criticism. So take the best AI out there when it comes to deep learning, image caption control, and throw out an image like this. And here's the text. This is what AI thinks this image is. A herd of sheep grazing on a lush hillside. And I really hope that the word lush will annoy people soon. And you look at this, and the human brain says, no, it's not. Those are a bunch of rocks. Maybe the AI got confused by the white rocks. Here's another one. A flock of birds sitting on top of a lush green field. Oh my gosh, stop it with the lush. What's wrong with this AI system? And actually, I did this morning. I took this image, and I ran it through IBM's image caption service. I was looking for one online. That's one that I found. And you can see, for AI being so amazing and fantastic, it is really failing to comprehend what is happening in this image. And when it fails catastrophically. Here's a group of flowers in a field. You want to confuse AI, change the color on something that's not normally that color, and that can confuse AI in some cases. So what's happening here? So just like birds inspired humans to fly, we went and built a 747, Boeing 747. And just like the human brain inspired people to build AI models, we're building GPT-3. And someday in the future, hopefully not, we'll have GPT 747. And I say hopefully not because hopefully we've improved our perspective. And the core criticism here is we're trying to predict the future. And how hard is it to predict the future? So talking to someone who's worked in semiconductor, worked at a hedge fund, worked at an HR company, I've worked for a variety of customers and clients. Predicting the future is hard. And even with these very powerful models, it is hard because features can shift, images can shift. A very large model trained on ImageNet can see things it never expected. We had a not safe for work model that I had trained at my previous company, and we trained it on a very large data set, I think 20 million images, something massive. And the model in production for one of our customers, it was giving false positives with babies. So babies in diapers, it was flagging them as not being safe for work. And what that goes to show you is just how brittle some of these deep learning systems can be. If they haven't seen it before, they will fail. So let's shift gears a little bit. We're going to dive into intelligence. So this is the coronavirus. It's wreaking havoc. Can you spot the intelligence? Is this intelligent? So let's really think about this for a second. Is this virus intelligent? Well, what does intelligence mean? Well, intelligence is to capture experience and knowledge to achieve goals. So a single virus is probably not intelligent, but maybe trillions and billions of viruses, they're achieving their goal quite well with self-replication. They're mutating, they're adapting, and we're paying the price for that. So maybe this is intelligent. Some people will say it's not living. Other people will say it could have some intelligence if you look at it from more holistically. If you look at all the viruses, maybe there's some concept of a goal attainment. And now let's level up in the animal kingdom. So here you have an ant. Is this ant intelligent? So really think hard about this. The very, very little brain. It actually has a bigger brain to body mass ratio than humans, but is this intelligent? I love this photo because hopefully it's steering you to the answer is no, it's not intelligent. I'm about to smash it to retaliate for this terrible bite. But now take a look at this. Are these ants intelligent? Wow. This is, we got some teamwork going on. They had a goal in mind. They needed to bridge this gap for some reason. Maybe they're going to have the colony begin to cross it. This looks very intelligent. There's actually algorithms that are inspired by intelligent ant behavior when it comes to navigating obstacles, and this falls into the class of some of these stochastic AI algorithms. So yeah, very, very interesting. And the thing I forgot to kind of steer in front of this is when we talk about the singularity or thinking machines, and a lot of times we talk about consciousness, and the thing I hope to show you is this intelligence scale where, and I'll get through it. So we'll go through a few slides and we'll talk about this intelligence versus consciousness. So here's a crow, and a crow, you have a certain class of birds that are really intelligent. Their brain to body mass ratios are quite high, and those include crows and jays. And there are crows that can solve problems that I think some of our own children would struggle with, especially young children, where it'll put rocks in a test tube to raise water to get a treat out. If you're curious, go look on YouTube. There are some very surprising, very intelligent behaviors of crows that are using sticks and different things to accomplish goals. Very, very smart. And dolphins. I love this now because I think before studying AI and intelligence, I was on a cruise ship. I saw dolphins jumping in front of the cruise ship. And why are they jumping? Well, they're jumping because they're playing. They're curious. To really set the stage for why dolphins are so smart, a dolphin brain is larger than our own brain. So a dolphin brain is 1,700, I think, grams, and then a human brain is 1,200. A great white shark is 35 grams. So a dolphin's brain is essentially 50 times larger than a great white shark. But they both have the same mass. They're both the same machine. And what that should tell you is to operate a great white shark, so a 1,000-pound animal in the water, it takes 35 grams of brain to do that. What that means is the shark doesn't have a lot left over. It doesn't have a lot left over for daydreaming, pondering, playing, curiosity, novelty. But when you look at very intelligent animals like octopus, dolphin, they will show play. They will show different social behaviors. And I love, here's another one. Elephants are incredibly smart. They have very, very large brains. And this elephant is showing signs of wonder. So what we're walking through here are behaviors that you can see in the animal kingdom that are mapped to intelligence. Here's a monkey laughing. So monkey has humor. Isn't this great? This is also a sign of intelligence, very high intelligence. But obviously humans are the best because no other animal is doing magic. Check this out. Humans kick ass. On stage doing magic. If you saw aliens that came to Earth, we should be pretty concerned if you stumbled upon them and they're doing a magic show to entertain a bunch of aliens by doing things that modify our understanding of the world or physics. So the other thing that makes humans the best is we can land rockets backwards, right? With SpaceX, no other animal can do that, so we're obviously the best. So why are we the best? What's going on here? I've built automatic speech recognition models before. So eat hot dogs. This mother might say eat hot dogs. It will go into a waveform and it will be turned into a spectrogram. This is how Deep Speech 2 works, by the way. And that spectrogram, which is now an image, it'll go through a very, very complicated deep net. I think if I remember correctly, our deep nets at HireVue, when you save them to disk, they were almost a gig. They're very, very large. And what this net will do is it'll produce a sequence of letters. And it's kind of nonsensical, and it has a few steps to correct that, and then it uses a language model, so it'll use an acoustic model to go from spectrogram to letter sequence, and then from that garbage that comes out of that, it'll use a language model to create eat hot dogs, and everyone in the AI community will celebrate. This is fantastic. By the way, we have exceeded, I believe, superhuman speech recognition, maybe not in production, but with some of the research groups. I know Microsoft claimed that they had achieved below, is it the 3% word error rate? Yeah, so the word error rate is kind of the holy grail. That's what we're trying to go underneath. And so we've achieved that for some research groups. But here's the bad news. Your cute, cute little baby, babies are great, aren't they? You say eat hot dogs. Let's pretend that the baby has never heard the word hot dog in its life, ever. The moment it hears eat hot dogs, not only does it break eaten hot dog, said in a single, it was very hard for the neural net to break that. It actually breaks hot dog in S. The baby brain will break that. The first time it heard hot dog, it breaks hot dog in its mind, in its mental model. How is it doing that? Why is it doing that? Well, for as much as I'd love to criticize human memory, the memory is remarkably good. It is looking through its experience very quickly and realizing that it's heard most likely it's heard the word hot and dog and with the plural ending S in the past. And so it is segmenting this new word that way. And we have seen examples where babies can learn things like this with one-shot learning. They hear it a single time and they have it. Where if babies are dyslexic or have other issues, maybe they have to hear it 100 times. But deep neural nets have to hear it many times more to learn something. The other thing I love about babies is not only are they smart about hearing words, they're really smart about emotional intelligence. So anticipating novelty reactions from a parent. So if this mother looks at a new toy and in surprise says Woogie, some nonsensical name, if the mother or father has not expressed that type of surprise at any of the other toys, the child will immediately know that this toy only is the Woogie and nothing else is the Woogie. And why is the child doing that? Why isn't it generalizing? So this absolutely fascinating. Then the other thing I like is this really complex way that humans learn what things are. You look at GPT-3 and you say, what is a dog? And it might show you a word cluster and some attributes around it that might make us feel good as AI researchers. But compared to what a human is doing, it's not really there yet, not even close. So the brilliant thing with a baby is you will show it a dog. Let's say this cute little dog here. It's seen the dog before. And if you touch the dog and say fluffy, the baby will not associate that thing as being fluffy. It will actually associate it as a fluffy dog. It won't replace the noun. It will now figure out that this is associated because of the way it was introduced. And so people are really, really good as we learn a language at figuring out these relationships between attributes. We start with nouns that'll go to verbs and adjectives, and we build out these very complex hierarchies in our mind. And one of the things I want to admit is I had a very negative take on linguists, and now I have a lot of respect for them. I've actually been reading some of these books about how children learn language and some of the experiments that have been done, because I feel like it's a real window to the soul or the early mind as we learn. If you want to go even simpler than language, you can begin to think about the physical world. How do children learn the physical world? Even if a child can never speak or never hear, it immediately begins learning to anticipate the world around it and how things and objects relate to each other. So here's a quick test, a test that deep learning would not do very well at. Here's my face. This is interesting. Not really. Maybe you could have a gender classifier. It's a man, it's a woman. There's nothing really surprising to anyone who's watching, and there's nothing surprising to deep learning. If I show you this, ear in my head and a missing eye, all the human brains that saw this are immediately going to look at the ear on the head and the eye. They're going to recognize it immediately, and they're going to kind of flag that as something is strange, something's bizarre. I would argue that most deep learning, especially early on, they would see nothing wrong with this. They'd actually classify this as a male with 99% accuracy, and I could shuffle the eyes and the nose and the mouth around. And that was kind of the inspiration for the capsule networks from Princeton to fix this. This is a trait that is not liked because this is not a very smart, not very robust way to protect against this. So the last thought I'll leave you with is people are already talking about this. There needs to be a new Turing test. So wherever you sit on kind of this discussion or debate about consciousness or superintelligence, we really have to define what the new line in the sand is. What are we fighting for? What's our new goal? What is something that would impress us? So GPT version 6 or 7, passing the Turing test it's an achievement. It's something that we should recognize, but it's not. It doesn't mean that it's conscious. It doesn't mean that it's general intelligence. General intelligent. It doesn't mean that it's going to be a breakthrough for droids or different things that can improve our lives. And so, as we think about the new Turing test, or the better Turing test, to actually hold AI accountable for knowledge acquisition, comprehension, and to really set the stage for where we're going, I think we kind of have to go back to the basics. And one of the Turing tests that was suggested was video comprehension. Oh, AI should be able to watch a bunch of sitcoms and should be put through a battery of tests. And I would say that's great. That's a great test. That's definitely better than the Turing test. But I would also say that's pretty advanced. And so this example that I'm showing is, imagine a Turing test of static images where the concept of time does not exist. Because time, I've dealt with video, time is complicated. Do you deal with, image sequences going through an LSTM or an N, or do you deal with with queues of images? Things get complicated. So imagine a world where there is no concept of time. You and your brain in a jar are looking through a window, and you see images of a field flashing in front of you, images of a kitchen, images of a face. This human mind, or this future AI, should be able to recognize novelty. So if an eye is missing, it'll recognize it. Or if it sees a faucet, it should actually anticipate where it might go. Well, it should go in the kitchen group. And I think I'd put it right here. And so the idea of relationships, whether they're spatially sized relationships, group relationships, daydreaming, anticipation, I would say we're hunting in the ballpark. Like, this is kind of the right discussion for us to be having with GPT-3 generation. But we really need to nail down the tasks that need to be demonstrated for us to really start to move in the right direction. And I think a lot of it will come from the inspiration of a child and how a child learns a language. So this is me. I'm on LinkedIn. I'm on Twitter. If you have a question that is not able to be answered, now that we're at the end of the talk, feel free to reach out. Twitter, I'll respond in a month. LinkedIn, I'll probably respond sooner if I can. If I don't respond, it could be because I'm busy. I'll try to respond to most people that reach out. So that's it. Let's go to Q&A. Hopefully there's some questions.
Well, I can certainly say that was an awesome keynote, Ben. Thank you so much for all the information. All our audience, I think, was stumped and thrilled at the same time. Now, I'd like to invite you to your very own Dsgo Live Q&A. The way it works is that attendees will send questions to the chat. I'll receive them, and then I'll forward them on to you. So, attendees, you know what to do. Send your questions to the chat, and we'll get started. So, we have this first question coming in right now, Ben. Manan Verma asks, what are your views on bias in AI and how to deal with it moving forward?
That's a great question. So some people have said that the bias needs to be eliminated from the data. So you do the pre-processing, get rid of it, and that's a very naive idea because bias is always present. Bias will always be there. So some of the work that my team did at HireVue is we would take data sets that had racism, they had sexism, they had age bias, and we came up with ways to remove features and do different model training behaviors where we could train a model and put it into production from a racist training set. So the best thing to do is to be proactive. A lot of people have been reactive. So if you see bad examples in the news, those are the oops examples, and I'd argue they were not proactive. They weren't having discussions before. But admitting that bias is always present, the unconscious bias is there, it allows us to finally begin to address it.
Awesome, wonderful. We have another question coming in, this time from David Primrose. What is your personal perspective on consciousness in reality versus in a GPT model?
Hopefully I understand this question. So my idea with GPT is not intelligent. Even if we had GPT a billion, it's quite dumb. It's a parlor trick. It's not alive, it's not living, it's not actually smart, it's a parlor trick. It can do cool things. I guess the joke there, which is a tangent, is I can convince my parents that I've created the singularity next year. But everyone on the call would say, no, you haven't. It's a parlor trick. You're tricking people. So I think we really have to move away from some of the core foundations that exist inside GPT-3 and different models, and we really have to go back to the drawing board, back to the human babies, and kind of understanding how they learn.
Okay, awesome. I think we have time for just one more question. Charlene asks, what are some of your best practices, or what you consider to be the most important aspects of AI and data training?
So best practices, always assume your models are wrong. Never be excited about a model that looks, if it's too good to be true, most likely it is. Solve problems backwards. So never use AI for AI's sake. Start with a problem we're solving. Go Z to A, don't go A to Z. So think about business value, not about tech academic interest.
Well, thank you so much. Thank you once again, Ben, for that wonderful keynote speech and the even greater Q&A. I know for a fact that the audience enjoyed every single moment of it.